Hi everyone, welcome to Observability Day Europe 2023. The topic we have today is Scaling Observability Stack for AIOPS. I am Ravi Hari. I work at Intuit as a Principal Software Engineer. About Intuit briefly, Intuit was founded in 1983 and it went to IPO in 93. We have about 19 locations and I work from Bangalore office. We have about 12.7 billion revenue last year. And we have more than 100+ million customers, and we contribute into multiple open source projects. Coming to the topic, briefly, Prometheus metrics are used for various purposes, and Prometheus being a de facto standard in Kubernetes, it can be leveraged for various use cases. For example, monitoring time series data, alerting, auto scaling and anomaly detection are common use cases for Prometheus metrics. The problem that we had to solve was we wanted to generate anomaly scores using AIOPS tools, leveraging Prometheus metrics data. And the thing is that Prometheus metrics that the Prometheus instances collect, it is good for a few hours, but we cannot store the data in Prometheus instances for days to live. And Prometheus also does a lot of other things like scraping, remote writing, and it also allows for querying, because of which we cannot retrieve the data with long-term storage directly from Prometheus. We had to choose other components. So we looked at all the solutions and we felt Thanos is a great fit with Prometheus, and we started integrating Prometheus with Thanos to scale horizontally. Thanos has a number of components like Thanos query, store, sidecar, ruler, etc. And one thing that actually we liked was Thanos sidecar, with the help of it running along with Prometheus, we can write the data of Prometheus DSDB into S3 buckets. So this is high-level architecture of Thanos, where the Thanos sidecar runs along with the Prometheus instances. And the shipper component of the Thanos sidecar writes the DSDB blocks into object storage, S3 bucket in our case. And Thanos query can be used to query the data using Thanos store as a gateway. And Thanos store retrieves the data from S3 bucket and passes it on to query, which can be leveraged by the clients. Additional components like ruler and compact would be helpful. Compact will be useful to compact the data in object storage. Ruler can be used for aggregating the roles if you have multiple Prometheus shards, so that we get consolidated when we use the roles. So we thought we use AWS S3 bucket to store the data, and we chose about 8 years of data would be a good historical data to query and run some anomaly detection on top of that metrics for a given use case, right? And retrieving this data from Thanos store, we pass it on to Thanos query as we have seen. So this architecture essentially looks like this for which we have initially enabled, right? So for querying the live metrics, we went directly to Prometheus. We didn't have too much traffic on this side, but we were anticipating more traffic coming towards the Thanos long-term storage metrics, because we wanted to run this anomaly scores and all the namespaces on a given cluster. And this is the path where it queries the Thanos query S3 service, and that calls this Thanos query 3 pods, because they are getting retrieved from S3. We are just naming it as S3 here. And this Thanos query S3 pods retrieve the data from Thanos store. Thanos store is a stateful set, and that can also be horizontally scaled. And they call the S3 buckets and they retrieve the data from S3, right? So that is a current model we have implemented with. And we have seen a number of challenges. This is the first challenge that we have seen, right? We thought everything would work with the previous architecture, but this was working only for the add-on namespaces or namespaces where we run the Kubernetes controllers, but it is not working for us in the application namespaces. The reason for that is our application namespace have high security guardrails, and because of which we have network policies that we put in place so that no two application services can contact each other, right? So we cannot query a service from an application namespace into either an add-on namespace or any other namespace as such, right? Then how can we query this data from to run it from the AIOPS pipeline in the namespaces, right? Then we thought of a solution called internal ALP, which we can put in place in front of this Thanos Query S3 service. Then the application namespace, whichever is running this AIOPS pipeline, can query the internal ALP to retrieve the data that eventually can call the Thanos Query S3 and store retrieve data from S3 bucket. So this pipeline can work is what we figured out. And we thought this will solve all our problems. Then we started running into other issues. The second issue that we ran is once we started load testing it, we found that Thanos query there is errors coming up quite frequently, and we are also seeing errors on the clients, right? And the error that we saw in the Thanos query is the chunk pool getting exhausted. And we thought initially this is a Thanos query problem, but later we realized this is essentially a problem coming from Thanos store. And when we looked into what are the possible options for us to configure with Thanos store, we came across two critical options in Thanos store. One is the chunk pool size configuration, and the other one is index cache size configuration. So the chunk pool size configuration, we started playing around by giving different sizes for it. And even when we gave around 30 GB for this chunk pool size, it was not sufficient. We were running out of it when we had run, high volume load test. Then we thought we need to keep this minimal because otherwise the Thanos store pods are going to have very huge amount of memory. So we optimized it in a later phase. I'll come to that. The other thing that we also found beneficial is index cache size. So this keeps the index data that gets stored in the TSDB blocks, which has the information of where the chunks are stored in the S3 bucket and other things, right? So by enabling this, it will optimize the speed to fetch the chunk data that is stored in the S3 bucket. And it doesn't have to retrieve this index file every time because it is stored in that memory. So these two options help us alleviate the chunk pool exhaustion problem that we were seeing in the Thanos. Now, after that, we found another issue that the ALPs are getting 504 gateway timeouts. And we were running the load test. Initially, we didn't see this, but after a certain point of time, after we fixed the chunk pool size configurations and stuff like that, we saw that the ALPs are giving this 504 gateway timeout errors, and we looked into the access path. We figured out that the ALPs are getting timed out. So there is this configuration in ALP called idle timeout. By default, it is set to 60 seconds. But because we are querying 8 days of data, the amount of time taken to retrieve the data from the S3 bucket and pass it on back to ALP is taking more than 60 seconds on the load. So which is why we are not able to get the metrics data back, and that connection is getting terminated after 60 seconds, and we were getting 504. So the fix for this is we had to increase the idle timeout on ALP, and then we were not seeing the 504 gateway timeout errors. Then we thought we are set, and we ran into another problem. And this problem is 502 bad gateways on ALP. And the reason for this is we thought it has to do with some timeout settings and other things, but later we found that as we started increasing the load, the Thanos store memory is getting exhausted quite fast. And at the same time, the memory from the node is also getting exhausted and reaching 100% quite fast. And then this Thanos store as it is not becoming accessible. And Thanos query S3, when it is trying to query Thanos store, it is getting a connection to this error. So with Thanos query getting connection refrigerator, the ALP is giving us a 502 bad gateway. Then we thought, hey, whatever we are doing is not right because we are querying too much of data, and that is overwhelming Thanos store. And we need to somehow reduce the amount of data that we can query at once from Thanos store, so we can limit the memory on the Thanos queries store, right? So as we discussed, we saw the 100% usage on the nodes and CPU on Thanos store, CPU and memory on Thanos are getting spiked immediately. We looked at a couple of alternatives. And the solution for this problem is we found how can we reduce the size of the data that we can retrieve. We thought of implementing our own solution, but we later found that there is already a well thought out solution for this called Thanos Query Frontend. And this provides us an option to split the query range with a split interval flag. And there we tried around different combinations during the load test, and we felt to us is a decent query split interval with which we can limit the amount of memory that Thanos store consumes and Thanos memory consumes. Because otherwise, if you don't have this and we query Thanos query, even if Thanos store sometimes performs well, Thanos query is running out of memory. So this one actually protects both Thanos query and Thanos store to retrieve the information, right? So this is our final solution. So the pipeline that runs in application namespaces queries the internal ALB, which queries the Thanos query frontend, which can horizontally scale. That internally queries the Thanos query, service, which can also horizontally scale, which queries Thanos store, which actually retrieves the data from a S3 bucket, and that can also horizontally scale. Now, with all this, we ran a load test and we didn't see any error after that. We saw that at 99 percentile, the response time is around 65 seconds, and on average, it's around 30 seconds. And these are the results on the backend, where we saw that the Thanos query, S3 CPU, and memory are in control, as well as the Thanos store query and memory and CPU are also in control. And we also saw that the HPA is getting kicked in at the right intervals, and these components can also scale, and the node memory usage and CPU are also within the limits. The next thing, once we have this thing running into it, right, the next big thing is how much does this cost for us, right, to have this solution? Then when we looked into the components that are involved in this, there are three components. One is ALB, the second one is nodes, the third one is S3 bucket. So first looking at the ALB cost, the ALBs are getting charged based on the LCUs, which is nothing but load balancer capacity units. And in our load test, based on all the information that we have, when we look into the amount of cost that gets charged, we query based on a load profile at the peak. We query about 35 GB per hour, and we have about 30 concurrent requests per second and stuff like that, or 30 connections that we create against the ALB per second. And based on all this, we saw that ALBs will get charged about $204 per month, which is not bad. And then we looked at the nodes usage, right? And how many nodes would be based on the instance type or the number of nodes were changing. We started with offset to start, but as we saw initially the memory was going and shows a very high order instance of R5 series because they are memory optimized. But later, as we were able to control the query range to 2 hours with the split interval, then we realized that it's no more a memory bound problem, it's essentially a compute problem. So we went with C5 instances, and with the C5 instances, when we looked into the on-demand instances, it was costing a little higher. But when we chose the reserved instances, the cost seems to be decent with even 2x order of instances. So overall cost that we felt with the C5 for extra instance rate is around $1460 US. And then the last thing is AWS S3 bucket cost. AWS S3 buckets are charged based on the amount of data that we store in them and the amount of data that we retrieve out of it and the scans it does to retrieve that data, right? And by feeding in all our information based on our projections and capacity estimates, we finally arrived at about $1,444 per month approximately, right? So overall cost based on our projections, it comes to about $3,100. This is a good insight for us. Now we can look into whether is this what for us to kind of build our own solution or look at any alternates that provide us out of the box solutions. But this seems to be much more optimal than going for any paid tools and stuff like that. That is all our learnings in scaling Thanos to retrieve longer term data for metrics that are generated from. Thank you.